Good evening. In the last lecture, we discussed the concept of harmonic progression and relation between three means: arithmetic mean, geometric mean, and harmonic mean. So let us solve some from exercise 2.4. Third one, find arithmetic mean of two positive numbers whose geometric mean and harmonic mean are 4 and 16/5 respectively. It's a playgroup sum. With usual notation, g square is h. What is asked in that sum? Arithmetic mean is asked. Okay. So rearrange the terms to get a equal to g square upon h. Now values are given. Substitute them. So a comes out to be 5. Right on. Fourth is similar. Find harmonic mean of two positive numbers whose arithmetic mean and geometric mean are 15/2 and 6 respectively. So h is g square upon a. So substitute the values to get harmonic mean as 24/5. Fifth one, find geometric mean of two positive numbers whose arithmetic mean and harmonic mean are 75 and 48 respectively. In exam, if this is asked for 2 to 3 marks, it is better if you say let A, G, H be arithmetic mean, geometric mean, and harmonic mean of two positive numbers respectively. We are given and we have, etc. Okay. Now G square is H, so G square comes out to be 3600. So G is plus minus 60, but we know that geometric mean is greater than harmonic mean. Harmonic mean is 48. So G has to be plus 60. Now sixth one we are going to discuss. Insert two numbers between 1/4 and 1/3 so that resulting sequence is an HP. See, inserting two numbers means inserting two harmonic means, because if there are n numbers between 1/4 and 1/3 and resulting sequence is HP, then those n numbers will be called as n harmonic means. But here they haven't used the word harmonic mean. Okay. Let the required numbers be h1 and h2 so that 1/4, h1, h2, 1/3 are in harmonic progression. Now, as per the definition of HP, the reciprocals of these numbers will be in arithmetic progression. So first term for AP is 4. Second term is this is third, this is fourth. Let A be the first term and D be the common difference. So what is fourth term formula? It is A plus 3D. Now fourth term is 3, right? So 4 plus 3D equal to 3 because A happens to be 4. That gives me D equal to minus 1/3. So what is the second term of an AP? It is 1/H1, which is 11/3. Similar, and therefore what is H1? Because 1/H1 is 11/3. We are interested in H1. So H1 is what? 3/11. See, this is not at all difficult. Similarly, 1/H2 is third term of an AP. It is A plus 2D, comes out to be 10/3. So what is H2? 3/10. Hence the required numbers are 3/11 and 3/10. Sum number 7. Insert two numbers between 1 and minus 27 so that resulting sequence is a geometric progression. Let G1, G2 be the required numbers so that 1, G1, G2, minus 27 are in geometric progression. For this geometric progression, first term is 1 and minus 27 happens to be the fourth term. But for GP, what is fourth term? ARQ. but a is 1. So we get r cube equal to minus 27. I hope you won't say r equal to plus minus 3. It is only minus 3. So what is G1? Second term, AR. So minus 3. What is G2? AR square. So 9. Now this is an important sum. If the arithmetic mean of two numbers exceeds geometric mean by 2 and their harmonic mean by 18/5, find the numbers. Let the two numbers be a and b. So we are given that a minus g is 2 and a minus h is what? It is 18/5. Now 2 minus 1 gives us, see, we express a and h in terms of g. So h comes out to be g minus 8/5. And what is a? From 1, a is nothing but g plus 2. Now we have relation g square equal to h. Substitute the values. You get g equal to 8. Now g is 8. So what is a? G plus 2, that is 10. But geometric mean is root AB. Root AB is 8. So AB is 64. Say equation number 3. Arithmetic mean is a plus b by 2. It is 10. So a plus b is 20. So what is b? 20 minus a. Put this value in 3. You get a quadratic equation in a. What are the roots? 4 and 16. Now when a is 4, what is b? 20 minus 4, that is 16. And when a is 16, what is b? 4. So you have to write final answer as numbers are 4 and 16. You should make it habit of verifying the answer. Verify the answer, see whether geometric mean is 8, arithmetic mean is 10, and so on. So numbers are 4 and 16. Right. Actually, 9th is similar, and that is for homework. I'll tell you the answer. Numbers are 4 and 9. The sum is similar to sum number 8. Find two numbers whose arithmetic mean exceeds their geometric mean by half and their harmonic mean by 25/26. Now we discuss sigma notation. Actually, you had done this in 10th standard in the topic statistics. Consider the sum T1 plus T2 plus T3 up to Tn for a given sequence. Basically, T1 plus T2 up to Tn is the sum of which sequence? Say T1, T2, T3 up to Tn. Now, this sum of n terms is denoted by using the Greek letter sigma. This is capital sigma, S-I-G-M-A. Actually, in statistics, we use small sigma also. This is small sigma, which is used to denote standard deviation. In fact, this is included in 11th standard syllabus in the topic measures of dispersion. So capital sigma stands for summation. This is Greek alphabet, and small sigma stands for standard deviation. Okay. So this particular sum, this is very interesting. This particular sum is written as sigma TR. R goes from 1 to n. Please do not read this as sigma into TR. There is no multiplication. So sigma TR, R goes from 1 to n. This is called as suffix. Now lower limit is 1. See, here we consider natural number only. Use common sense. Will you say first term, 1.7th term, root 11th term? That is absurd. So this has to be a natural number, naturally. So lower limit is 1. So T1. Now sigma stands for summation. So plus, next value will be 2. Till what? Till Tn. I repeat, Sn. You have to remember this. That what is Sn? Sum. It is nothing but sigma Tr. R goes from 1 to n. Now you may also ask me, is it necessary to write sigma Tr? Can we write sigma Tn? Yes, you can write sigma Tp also. you can do TP also. In that case, P will go from 1 to n, as simple as that. But usually we go for sigma TR, R goes from 1 to n. Okay, I'll give examples. See, if I say T4 plus T5 plus T6, I can write this as sigma TR. R goes from 4 to 6. This is the advantage of sigma notation over SN notation. Will you say T4 plus T5 plus T6 is S3? No, S3 means sum of the, and that too, first 3 terms. Of course, you can write this as S6 minus S3. It is possible, but this is better notation. Okay. So this is about sigma notation. Now, there are some properties of sigma notation. The first property is sigma of sum is sum of sigmas. It is quite logical. I'll tell you what do I mean by this. Sigma, say instead of x, I will use sigma AR plus BR. R goes from 1 to n. What is sigma of sum? Sum of sigmas means sigma AR, R goes from 1 to n plus sigma BR. See, it is all about using common sense. I'll give example. AR, BR, AR plus BR values. Say 1, 2, 2, minus 1, 3, 2. Okay. So we have to verify what is sigma AR? It is 6. What is sigma BR? It is 3 because 2 plus 2 minus 1 is 3. Okay. Now individually you have to find AR plus BR. 1 plus 2, 3. 2 plus minus 1, 1. 3 plus 2, 5. Now add. So this is nothing but 9. Now just verify. This is sigma of sum. So sum of AR plus BR values 9. Is it sigma AR plus sigma BR? Yes, 6 plus 3. As simple as that. Similarly, sigma of difference is difference of sigma. I hope you will not say that sigma of product is product of sigmas. That is absurd. We will verify that. AR into BR. So what are the values for AR into BR? 1 into 2. See the cursor. 1 into 2 is 2. Then 2 into minus 1 is minus 2. 3 into 2 is 6. So what is the addition? 6. Now tell me, is sigma AR into sigma BR, that is 6 into 3 6? No. I hope this is clear to you. Okay. Again, this is common sense. Sigma KAR, R goes from 1 to n. See, variable is R. So we can take K outside sigma notation. So it is K into sigma AR, R goes from 1 to n. Now finally, sigma 1, you have to tell me the value. Type your answer in chat box. Sigma 1, R goes from 1 to n. Yes, can you tell me? Type your answer in chat box. Very good. The correct answer is n. Correct answer is n. I'll tell you the reason. Basically, what does some students are saying sigma 1 is 1. No. One student is saying, but sir, there is no R. Okay. See, now R is involved. Can I write 1 as R raised to 0? Yes. R goes from 1 to n. Put R equal to lower limit. See, this 1 is called as lower limit and n is upper limit. So what is 1 raised to 0? 1. Sigma stands for summation. So plus next value of R, 2. What is 2 raised to 0? 1 till upper limit n. N raised to 0 is also 1. So 1 plus 1 plus 1, how many times? n times. Is that clear? So what is sigma 1? It is nothing but n. Now we are going to discuss three important sums. Number one, sum of the first n natural numbers. Actually, you had done this in 10 standard because first n natural numbers are in arithmetic progression. You know that it is n into n plus 1 by 2. Second, sum of the squares of first n natural numbers. And third will be sum of the SUM sum of the cubes of first n natural numbers. We are going to use this altogether different method. This is very interesting. We begin with, as we have to find sum of the first n natural numbers, we begin with x square minus x minus 1 square equal to. In case of sum of the squares, we will begin with x cube minus x minus 1 cube equal to. Okay. Now, what is x square minus x minus 1 square? Substitute the values. You get 2x minus 1. Now, in this, put x equal to 1, 2, 3 up to n in succession. So, 1 square minus 0 square is 2 into 1 minus 1. Put x equal to 2. 2 square minus 1 square, 2 into 2 minus 1 up to n. Here you will notice that what is natural number before n? N minus 1. So it is n minus 1 square minus n minus 2 square equal to this. And finally, n square minus n minus 1 square equal to 2n minus 1. Consider left hand side. If you add, 1 square gets cancelled, 2 square gets cancelled. So what remains is this n square. See the cursor. N square minus 0 square. That is n square. Now on right hand side, you have to add column wise. Column wise means vertically. So take 2 common because each term contains 2. So if you take 2 common in bracket, you get 1 plus 2 plus 3 up to n. Take minus n common, 1 plus 1 plus 1. How many times? N times. Now we are interested in this only 1 plus 2 plus 3 up to n, which is written in short as sigma r. R goes from 1 to n. Okay. Rearrange the terms. So twice sigma r is this. Take n common to get n plus 1. But we are interested in sigma r. So divide by 2. Yes. Sigma r, that is sum of the first n natural numbers, is n into n plus 1 by 2. Now we can use another method only in this case because numbers 1, 2, 3 up to n form an AP, arithmetic progression, with first term 1 and common difference 1. Use the formula to get the same. To get the same. Okay. So write down, give the title, 3 important sums. Number 1, sum of first n natural numbers, 1 plus 2 plus 3 up to n, that is sigma r. R goes from 1 to n, is n into n plus 1 by 2. Second, we are going to prove this. Sum of the squares of first n natural numbers, that is 1 square plus 2 square plus 3 square up to n square, that is sigma r square. R goes from 1 to n, is what? N into n plus 1 into 2n plus 1 upon 6. Now we prove this. We have x cube minus x minus 1 cube equal to, I will directly write, so minus x cube plus 3x square minus 3x plus 1. If you want, you can have one more step. That is finally x cube minus x minus 1 cube equal to what? 3x square minus 3x plus 1. Right now. Now put x equal to 1, 2, 3 up to n in succession. So 1 cube minus 0 cube equal to 3 into 1 square minus 3 into 1 plus 1. 2 cube minus 1 cube is this. Up to what? N cube minus n minus 1 cube equal to 3n square minus 3n plus 1. On adding column wise on RHS. Okay. Now on left hand side, what remains is n cube. See, this is not at all difficult and similar to the previous one. Now, if you take 3 common from the first column, you get 1 square plus 2 square plus 3 square up to n square. That is the required sum. From second column, take minus 3 common. 1 plus 2 plus 3 up to n. We can use this directly. And 1 plus 1 plus 1, how many times? N times. Right down. Therefore, n cube equal to, now this is just 3 times sigma r, sigma r square required sum. R goes from 1 to n. Ideally, I should write minus 3 into what? Sigma r. But I will not write that. I will directly say, I know what is sigma r. It is n into n plus 1 upon 2. And 1 plus 1 plus 1, how many times? N times is n. That's it. Now you have to solve this equation for what? 3 times sigma r square. And finally divide by 3 to get sigma r square. So if you rearrange the terms, then what is 3 times sigma r square? N cube plus 3n into n plus 1 by 2 minus n. Here I have omitted one step. In fact, 2 steps are written in one step. So LCM is 2. Now n cube minus n. Take n common from n cube minus n. It is n into n square minus 1. But LCM is 2. That is why 2n. Now what are the factors of n square minus 1? N minus 1 into n plus 1. Now what can be taken common? N into n plus 1 can be taken common. N into n plus 1. So in bracket, what remains is 2 times n minus 1. That is 2n minus 2. Now this is taken common. So plus 3. And therefore n into n plus 1. Into 2n plus 1 upon 2. But note that it is 3 times sigma r square. So what is sigma r square? Divide both sides by 3 to get n into n plus 1 into 2n plus 1 upon 6. Right. See, you have to use this as standard formula. Sum of the squares of first n natural numbers is n into n plus 1 into 2n plus 1 upon 6. One student is asking, why can't we use shortcut method in this case as in the previous case? See, in previous case, numbers were in AP. Ready-made formula is there to find sum of the first n terms. Here, 1 square is 1, 2 square, 4, 3 square, 9. 1, 4, 9, 16 are neither in AP nor in GP. So there is no ready-made formula. And therefore, we use this method. Now, sum of the cubes of first n natural numbers, that is 1 cube plus 2 cube plus 3 cube up to n cube, we have to prove that it is n square into n plus 1 square by 4. You may observe that this is right hand side is square of what? N into n plus 1 by 2. Right? This is just a coincidence. We cannot draw any conclusion from this. Now using sigma notation, sigma r cube is this. So we begin with, there is no, okay, there is. We know that x minus 1 raised to 4. Now you will ask me how to get this. See, at present, you have to use donkey method only. But once you learn binomial theorem, you can write this directly. So at present, I will say What is x minus 1 raised to 4? It is square of x minus 1. Rather, it is square of x minus 1 square. And what is x minus 1 square? X square minus 2x plus 1. Again, square that to get this. So, x raised to 4 minus this comes out to be this. Same logic. Put x equal to 1, 2, 3 up to n in succession. And then add column wise. Column wise means vertically on right hand side. On left hand side, what remains? N raised to 4 minus 0 raised to 4. That is n raised to 4. See the first column. Take 4 common. 1 cube plus 2 cube up to n cube. This is the required sum. Take minus 6 common. 1 square plus 2 square up to n square. We have just obtained this. In exam, you can directly replace this by n into n plus 1 into 2n plus 1 by 6. Third column, take 4 common. 1 plus 2 plus 3 up to n. We know that this is n into n plus 1 by 2. Minus 1 is taken common. 1 plus 1 plus 1. N times is n. See. So n raised to 4 equal to this. Rearrange the terms because we are interested in this. Sigma r cube. So what is sigma r cube? N raised to 4 plus 6 sigma r square minus 4 sigma r plus sigma 1. What is difficult? Addition of fractions. Now substitute the values. Actually, this is not difficult because 6 gets cancelled. So fractions are not involved. So this is n raised to 4 plus n into n plus 1 into 2n plus 1 minus 2n into n plus 1 plus n. Now see how this is simplified. In fact, they have just opened all the brackets. Otherwise, you can say that from n raised to 4 and n, take n common and so on. But I think this is also a good approach. Just open all the brackets. And what remains is this. N raised to 4 plus 2n cube plus n square. Take n square common. Because see, in exam, if this is asked, you will be knowing the answer. You will know that you should get n square into n plus 1 square. See, n square plus 2n plus 1 is square of n plus 1 only. So what is sigma r cube? Sigma r cube is n square into n plus 1 square by 4 because this is 4 times. Yes, we have to prove this only. Observe that sigma r cube is nothing but square of sigma r. Is that clear? You are supposed to write this in your notebook, but usually in exam, they ask some of the squares of first n natural numbers instead of asking sigma r and sigma r cube. So that's it for today.